So this set of slides, we're moving into chapter 4 of the book, talking about presentation. We kind of figure out how to take data and encode it as some visual representation. And then what kind of maintaining the same encoding. So if I decide that my x-axis are going to be the amount of money and my y-axis is going to be the amount of jobs, which by the way is one of the graphs in the homework. And I'm going to show everything as a big circle or a smaller circle and so forth. So I determine my encoding, which is the representation. That would be chapter 3. Or I decided to show something as a node link diagram. Then on the presentation part is, what do I do if I have a lot of data? I mean, the simplest way of presentation is I use a scroll bar. I go ahead and scroll through, and that's it. I have a kind of an infinite visualization and scroll through it. That may not work for everything, but I'm just giving you an example. And because I really didn't have a place to put it, I think rearrangement is also an important part, figuring out the right order for visualization. And again, I think there was a presentation today that looked at that. They changed the order of the nodes. So I'm going to start a little bit with rearrangement, try to convince you that it's a good thing to do. I have a very, very simple example in Excel, and then there's a more complex tool that we can look at called table lens. And then looking at large data sets, then we talk about these ideas of representation, a presentation of the information. And I hope I get to it, but I want to go to the information mural, which I think is a really nice technique that everybody ignores. I can make a lot of things look so much better. But for some reason, I think it's an interesting paper, but people kind of ignore it. So for the rearrangement, let me kind of show you. I have a very simple Excel example on the power of rearrangement, and then we're going to look at table lens. You can see, I think it started I want to say it started at Xerox PARC, or maybe not, but at least the authors used to be a Xerox PARC, and they formed this company inside, and they were bought by Business Objects and SAP and so forth. But we have a video that we can look. In the past, I was able to actually do a live demo. They had a website to play with it. But I think the video is good enough. So let me share the screen. And here's my Excel file. So what I did here, really I have a random number generator on the column D, but let's assume for weddings, I'm doing headgear for the bride and the groom, and for each of them I measure basically 2 attributes, the gender and the size, circumference, or if you want the waist circumference, whichever you want. And here is a representation of that data. Can you gather anything from it? Not much. Let me order it. So let's try and order by this attribute first. Which one do you have plotted? A and B. I mean, A is not plotted. B, but I just order based on B. D is no, it's just I'll show you what B is in a second. You'll see what D is as I get there. But if I order them, then yes, I can see some straight going up and down. Do I see much? I mean, even here, you can notice that ladies tend to be a lot smaller in whatever I was measuring than men, but there's an area of overlap. Here's another way to order these. I'm going to go to column A and order them. So here are, now you can start see the pattern. So all the ladies are first, men come second. And it's obvious that, you can see the overlap and everything else. So this representation it's the best. All I did, I had the same data, I had the same encoding, I just changed the order in which I presented it. You kind of see how there's an overlap and the two are separated. And I was telling you that I was generating this data based on a random number generator. And I think for women, I was using 51 plus, and for men, I was using 53 plus. So it was a difference of 2, just the way they were generated. But you won't be able to see it until you order it in the right way. That, again, that's my whole point. So kind of going back to this order shows something, but it's not, I don't know, it's not that clear. I have to still look at the spreadsheet. This one is completely random. It doesn't give me any clue of anything that's happening. So by just reordering, I can kind of see, you can see where the average here is, what was 53 and 51 plus random number times 5. So I need to add 2.5 from that 5. It doesn't matter. Anything I'm telling you makes no. I'm just saying what you're seeing. And here is the kind of the same concept taken to extreme. So let's look at table lengths. Like I said, they started from Xerox because this is copyrighted by Xerox. Okay, let's see. Do I have? They said they have a high resolution. See if there's any difference. Okay, I think you kind of seen all the features. One interesting one that I mean, the one that I was really focusing was the rearrangement, and you kind of see where you can look for correlations and things like those. But they also have that idea. I'm going to run into next set of slides. If we get there, a focus plus context, so I can see some data in detail while seeing everything else around it. And then I guess the other thing was using the spotlight, the red things that we're just doing at the end. So all of these make table lengths just taking an Excel spreadsheet and making it more easily available. But it does have to be in Excel. I'm pretty sure that was not a Microsoft product there they were using. So I'm navigating back to my slides. So that was my 2 cents on rearrangement. And again, for your project, it may be very important in the order in which you place things. Yes, they may be in some order in a database, but it may be more helpful if you rearrange them. Sometimes you can rearrange them in Excel, as I showed you. Tableau also allows you to rearrange items just to get the right order that you're looking for. So there's quite a lot of things you can do. Tree map doesn't allow you to, unless you do a hierarchy. You can kind of group things by adding some sort of artificial hierarchy in a tree map. So you basically group by agency type, for example, and then you group by something else inside the agency, and that would get all the CDs that have low number of TET. You can put them in one category and then large in another. So kind of going back to the large data sets, what that means is I have a lot of rows. In the case of table lengths that we just watched, they had like 300 rows. That may be a large data set for the time, but nowadays we have probably tens of thousands, if not millions, sometimes of entries. Okay, so when I guess what I'm trying to make clear is that a large data set has, if I were to put it in a spreadsheet, it has a large number of rows. There's also data sets that have a large number of columns. Those are called multidimensional or complex. And there's obviously sets that can have both. So that's kind of to keep that one solution to visualize large sets of data, which I currently use, I've been using for a while, is to have them on the desk and all over the office, put in clumps and piles, and that I take care of that data that way. The other one, like I was telling you, is this idea of scrolling. So I have something that's really long, I guess the best way, think of it as text, but it doesn't have to be text necessarily. It can be any kind of information. And I can scroll up and down. What's the problem with scrolling is that if there is a big pattern that I should be able to see, that kind of goes over multiple pages, I'm not going to be able to perceive it. It's not easy to perceive. So that's one thing with the scrolling. I see a lot of detail, but only of a relatively narrow area. So if there's a pattern that goes over 300 pages, it's going to be really hard to detect that way. I have to go through it many times before I will do it. Searching also not that great. So again, imagine you have a really large document and you try to get the section that talks about maps. Well, if that's all you know, scrolling up and down until you see the word maps or you see maps, that's the only way you can scroll. So again, if there's 300 or 1,000 pages, it'll take you a while to find it, and you may even skip it. Now, for scrolling, let me kind of, I think the way to analyze this on how efficient it is, I have it on the next slide, but there's 2 ways of scrolling if you want to, maybe 3 ways nowadays. So if I don't have a mouse or a window, how can I scroll? Most of the time, I will have some sort of button here that kind of tell me go one page up and 1 page down. So I can click on it that way. Kroger checkout may be one example where if you kind of search for produce, you can scroll to the next page of produce to see what you're looking for. So that's one example. That scrolling is not based on a mouse. Now, if you have a mouse in order to measure how efficient is scrolling for what I have right now, having 2 buttons, it's the easiest way in a way because all I have to do is count the number of clicks. How many times do I have to click on a button to get somewhere? To go from top to bottom or to jump to halfway through the document. So that's what I mean by how efficient it is. And now if I have a mouse and a scroll bar, then, with the mouse, I can also do a page up and page down. So it's really the same thing, but I can also grab the scroll bar and move it. So in order to measure efficiency in that case, it'll be the distance, if you want to count the number of pixels that I have to move. But it's not only the distance, it's also the precision, because, in this case, let me see, if you have a document with lots of pages, with 1,000 pages, and you open it up in PDF, your scroll bar, if you move 1 pixel down, you may jump 3 pages down, the way it ends up. So I kind of have to consider both how long it takes and the target area that I have to hit. Is it a pixel or is it 10 pixels? 10 pixels are a lot easier to hit than 1 single pixel. And sometimes it may be less than a pixel where I have to scroll, which is not possible at all. So it means that every time I move 1 pixel down, I end up going 10 pages down. So I'm missing parts of the document. So that's one way. And the third one that is starting to be more popular lately, again, if you have a smartphone and then you kind of flick your finger down. And in a way, it kind of goes back to a button push, but instead of going down 1 page, you maybe go down 3 pages, depending on how fast you're scrolling. So there's a speed associated to it. So for the most part, what I'm talking about, I kind of try to narrow it down to a button, but it's applicable to this and that. But instead of number of clicks, you would look for distance that you need to travel and how fast you need to go in terms of a touch screen. And then if we're using a mouse, going to keep it's how much do I have to move the mouse and how big is my target areas that I need to hit in order to find my information. So a long time ago, they tried to categorize this. I haven't seen much follow-up. In the end, people were not that interested on. They tried to measure visualizations like you measure a computer program. So, for example, to sort an array of files, I can write a computer program to do it in. So if I have to sort n files, then I can sort in n times log n. That's how many operations it'll take me. So they're trying to do something similar for visualization. It's like, how big is the visualization going to be in terms of how many items am I display? So if I have to display 1 million items, how long will it take me to go from one end of that visualization to the other? Do I have to do 1 million clicks? Or do I have to do a square root of a number of clicks? And so that square root of 1 million is what? I want to say about 10,000, roughly, somewhere in that neighborhood, between 10,000 and 1,000. No, it's exactly 1,000. It's 1,000. So that's obviously a big reduction if I'm able to do that. So that's where this this technique comes to. So choice number one, it's simple search. So if I have n items, so I have n items kind of listed this way in my visualization, and I can see a number. It almost doesn't matter how many I can see at a time, if it's a reasonable number. So if I have 1 million and I can see 3 at a time, or I can see 7 at a time, it's not going to make any difference. 1 million is what really matters at that point. Okay, so if I have this and I can go up and down, they call this the diameter of the visualization. So how long will it take me to travel from one end to the other of the visualization? About 1 million clicks. So that's, like I said, if the numbers here are really small of the items that I can display, then it makes no difference. It'll take me about 1 million clicks minus the number of things I see on the screen. So that they call that a visualization of diameter n. And again, to kind of be in line with computers, kind of the same problem. What if I have 1 million items here, but now my scrolling is a little bit smarter. I can go one page up, one page down. But what if I have a button here that allows me to go halfway through down? And one that allows me to go halfway up. So if I can go halfway through, it doesn't matter that there's 1 million items, I already skip about 500K, and I'm going to be in the middle the first time I click. And then I go halfway through, I skip another 250K, so I'm right here. And then I go halfway, go skip another 125. So the closer I get to my target, I can use a little bit smaller. So that ends up being, the diameter ends up being proportional to log of n. Because it's binary, it's going to be log base 2. So how much is that out of a 1 million? Log base 2, it's going to be, I used to know this. It's basically how many digits do I need to encode 1 million in binary. So I need 10 digits for 1,000. Okay, so I need about 20 clicks. So 1 million ends up being about 20 clicks. Thank you. But this is not going to be very, I mean, it's not that intuitive, obviously. It's easier to go up and down. It's kind of harder to jump halfway through and then jump a little bit halfway through whatever is left and halfway through. And then if you need to go back up, kind of use that button. But one way that can be really efficient is to, instead of using one linear part, so let's say I need to display, I'm going to do it for something like 9 items. Instead of having 9 bars that go down this way, I can have 1, 2, 3, 1, 2, 3, 1, 2, 3. And then my screen will have an up, down, left, and right. So as you can see, 9 items, in about 3 moves, I can go anywhere. So the diameter of this visualization is 3. It becomes square root of n. So it works really well for a million. You still have to do, I just said 1,000. That's the square root of a million. But it's more intuitive. It's a lot of two-dimensional data. You would have it kind of by definition put into. You can kind of scroll up and down, left and right. So that's these are kind of the 3 things they talk about in that paper. So like I said, simple scrolling is going to be proportional to the number of items. If you make scrolling more efficient in the sense that you can jump halfway through whatever is left, then you can go from one end to the other in about log n, but it's not as intuitive. And then really the best way would be to arrange data in a 2-dimensional or 3-dimensional pattern, and then you can kind of scroll up, down, left, and right. I don't know about 3D. Going in and out of the screen is not that intuitive, but it's possible you could do it. So that would become the diameter of the visualization becomes square root of the number of items. If you want the number of full screens that you need to move from one end to the other of the visualization.
Like the easy chooser where you scroll and then it merges later and then it expands.
That's more of a focus and context thing, like table lens, where they have a focus area and everything else is small. So they make it where everything fits on one screen. That's it. There's no scrolling. It's just focusing. So you put more real estate. You allow more real estate for some data points and then less real estate for others.
I guess you're scrolling, but you're not scrolling.
Yes.
You're scrolling, but you're using a different technique.
Yes, that's called, like I said, it's going to be focus plus context. And the first technique I want to cover is this one. There is a difference in visualization in what they call overview and detail versus focus plus context. So focus plus context, we can talk more about next time and the differences. But here, this lecture will focus on overview and detail. And here's a game. And then the way this game is played is you can see a little bit of a green bar here. And then I control this ship, and then I think each building is also something I need to build. There's builders that are sitting there. I forgot the name of the game, but Age of Empires. So I have a detailed view where I can see my map, and I can scroll left and right through the map. But in order for me to kind of get an overview and see everything, I have something called an overview right at the bottom, and I see everything. Each and every red dot and magenta, it's a different kind of empire. So normally they're either allies or they fight with each other, but you can kind of recognize it that way. I think blue is always me. I don't know, I can't remember. And red is some other empire. You can see there's a lot of red here, there's a lot of green, there's a lot of magenta right there. So I'm able to see the whole map. I'm able to see rivers. You can kind of see some blue river bodies and everything else that's built out there. So I know where to send my ships, because ships obviously cannot go on dry land. They need to be on a river or on a sea. So this whole technique, I have 2 visualizations, one that shows me an overview and the other one that shows the detail. And besides scrolling now, what I can do if I want to go to the red area, all I have to do is click on it, and then my detail would go there. And I'm going to start seeing details about the red area that are available. So now with one click, I can jump all over the map. So that's kind of, it's a little bit better. And it allows me to see high-level patterns. I can see where one empire begins and the other one ends. And that's pretty much a standard technique. So that's the basics. I have two views. So here are some of the problems I may run into, and some of them I think I cover next. So because views are detached, I need to switch back and forth between them. So in order to understand, I can understand the higher level and the lower level, but then I'm not sure exactly. For example, look here in this area. I don't know exactly what's right up here. Even if I just clicked here, it's not going to be that easy to put the two together. So that's the need to connect the position. What if something happens in more than one place? What if I'm fighting two battles at the same time, or they attack me from two different positions? This is going to be a pain because I need to switch back and forth. And the whole idea of visualization is to help me not remember stuff in my head and hopefully have it in the visualization. How much the zoom factor can be clear in a second. What if there is too much data for the overview, and that's where I have that information mural. And then some, if you want some best practices about overview in detail and how to use them. So kind of the first try of overview in detail is to have a magnifying glass. Then you can move around rather than have two separate views. The problem is that the magnifying glass obscures the map. I don't see the full map. I don't see anything that happens here on the map, for example. So the idea here is that I can move and change it dynamically and move around rather than just click and completely jump over there. So that would be an advantage. Well, how can I deal with the fact that the immediate neighborhood is obscured? I can just take the detail view, and notice I kind of moved it a little bit this way. So now I can see where this road is going that I'm watching here. One continues this way. Notice that that was not visible in here. Here's another solution. What if I put the overview and detail on top of each other and have one of them semi-transparent or both? So here is the overview. Here is my detail. Here is the focus area. And then I put everything together. What do you think? Would that ever work? It's a trick question, but it doesn't work statically. It looks pretty awful. But let me show you a video. Now on the video, while we switch that, let me kind of, the caveat is they didn't build that to be an overview over detail. It just happened to use that technique. You'll see what happens in a video. This was a collaborative tool where two people would work together at the same time and on the same thing. So they wanted to kind of have an overview of everything that's going on plus my detailed view. Okay, so the video, I think it's on Blackboard. So I'm going to show you this video later on also for focus plus context, but I have it here as an example of how that will work. Before I started, if you look at it, you can see there's a graph they're working on laying, two people working on laying out a graph. But here is the overview, you kind of see it in gray, and then the detail has blue and red colors. Okay, so let me kind of play it. It's a relatively short one. I only took. This graph shows the entire space, right? That's the back. Okay, well, you saw when you actually navigate through it, it makes more sense because the overview is fixed. It's not going to move, and while you move through it, you can easily kind of figure out where you are and what the overview is. So it's not as bad as it looks. Say what?
Simpler data set.
It is a simpler data set, yes. A very complex one, then yeah, you run out of almost graphical attributes to use, colors and. So let me go back to the slides. Okay, so that was an idea. Again, it looks like statically it's going to be hard to detect, but again, if I were to move, you would see the big thing moving, and then everything else, the background stays there. So it kind of works. It's not ideal. So these were some of the problems there. Need to switch back and forth between the views. The solution was, why not add like a magnifying glass metaphor, and I can see both of them at the same time. But that would obscure. Then I have to kind of shift my view a little bit. And the other one was connect the position in one view with the position in another. So it's not always easy to kind of follow which I'm attacking this way, but I'm attacking the right thing in the detailed view from what I'm seeing, or I may be slightly off and I'm attacking something that's no value or doesn't attack me yet. What if something happens in more than one place? This is the solution. I have two details. So there's no rule that I cannot have more than one detail. So this is a one detail that has links here, university, and this is the interchange right there. So I can see the overview of the map and details. It was just something I took off Google Earth or something a long time ago. Yahoo, actually, Yahoo Maps. Hey. So I can have more than one detail. There's no, but then I would have to kind of deal with them. There's three of them that if they go on top of each other, it's like dealing with windows, multiple windows on a computer. As far as the zoom factor, here is our galaxy. And so can this be an overview? And then the detail should be this classroom or this building. That's not reasonable. It doesn't matter where I click. I'll be thousands of light years away from it. I'll be in the middle of nowhere. So having too much of a zoom factor, you can see it's not reasonable. So there must be some limitations there. I'm exaggerating here, but kind of you get the idea. So if I want to use this as an overview, I cannot move from this building to the next building by just clicking. The overview is pretty much useless in this case. Doesn't show anything about, not even Earth is not there. So. But they have a solution for this. Why not have multiple kind of intermediate overviews? So here is an example that has a detailed view of Paris. You can kind of see the neighborhood of Paris, and then you can see a map of the entire Europe. And now if I want to navigate somewhere, if I want to go to Germany, I would just move this window here. And I would think that this will change, and then I can click on Berlin, just like I clicked here. You can see that, you can see how Paris is selected, the black rectangle there. And then I will see more information about Berlin. So I can have this kind of intermediate steps. I can have 2, 3, 4 of them. 10 of them will probably be too many, but a reasonable number I can handle relatively high level different zoom ratios. I'm done with that. Now, what if there's too much data even for the overview? Or maybe the other question is here, how can I have a better overview? If I go back to this, notice how here I have a lot of red dots on top of each other. There may be two people close to each other and there's two red dots, but they're so close they show up as one. And I won't be able to count them. And here's where the information mural comes in, but this really will take me more than 5 minutes to explain, I don't think. So I'd rather skip it. We'll do this next time. I'll return to it. These are some examples of what they were doing. Again, you maybe understand them better. And then from this paper, there's a paper that Catherine Pleasant, I guess, she's from HCIL, the Maryland thing, the tree map people. She has a paper got how to use overview and detail, which one the best. Here I have one slide to kind of summarize what we use. So if we're doing some sort of computer-aided design software, or I'm trying to create a 3D character in 3D Studio Max, or draw a detailed map of this building, like a CAD drawing, then if you think about those tools, they use, most of the screen is taken by the detail. You have a little bit of an overview somewhere to kind of navigate from one end of your screen to the other, but most of the real estate is going to be taken by the detail. It's almost like my game, but the game is slightly different. If for a game, exploration is important. In fact, in Age of Empires, that entire overview is not shown initially. You only show parts of it. You have to kind of send your troops to find more. But it's a game. Now, you don't want to make it as complicated for data analysis. But for the most part, overview may not always be completely known. And fast navigation is important. Maybe one example of that would be if you go to Google Earth, Google Maps, to map software, and you zoom out, it may take a while for the map to fill in, but they still allow you to zoom out and kind of navigate. If you want to go and see parts of Paris right now, if you start Google Maps, it'll start you up wherever your location is, probably close to Little Rock if you're around here. And then what's the best way to go to Germany? You're not going to keep scrolling, because every scroll will take you maybe 10, 20 miles away from here. It'll be a lot of panning that way. So what you want to do is zoom out and not even wait for the screen to refresh, kind of click on somewhere in Europe and then narrow it down later. So that's kind of, it allows you to explore. So the overview may not always be complete and focus on navigation. Diagnostics, like circuit design, I think it's like image generation, about the same thing. You want to have a lot of details and complete coverage, no gaming. Exploration is more for gaming. Navigation. So imagine a truck driver. I want to see the whole route, but I'm not interested in a gas station that's 300 miles away from me. So things that are close by, I'd like to see them together with an overview of the whole route from point A to point B. So monitoring, like security, I mean, most security cameras don't even have an overview. They just have a bunch of details. If you have an overview, that's best. You may have kind of the locations where the cameras are located, are spread out in the building, small overview. But then my details should allow me to move fast from one to the other and see multiple ones and zoom on multiple locations. So that's my 2 cents here. And we'll get back to the information mural next time. Here's how nice it looks.